let's get started. First some quick bookkeeping. We have a bunch of materials for this part of the talk, including stuff that you'll need for the group activity later on. This is an open share drive on Google Drive. You get there by following the URL tiny.cc/CySER, CySERED. And so we've got some worksheets and instructions and other materials just for your own reference that I'll be talking about. Yeah, CySERED. So the slides are there, some other materials. So my name is James Crabb. My background is originally in horticulture. I got a doctorate in that. While I was doing that, I actually discovered I was more interested in the tools, the data handling software. So I ended up moving over to computer science, got a bachelor's degree last year, and now I'm working on a master's with Dr. Hundhausen in cybersecurity education. This we went over. So to prepare everyone for our group activity later on this morning, I'm going to be talking about a tool in educational psychology called Bloom's taxonomy. I'll cover that fairly quickly just to get everyone familiarized with it. And then I'll be looking at sharing with you some published recommendations that exist with regards to important topics in cybersecurity education, things that experts in the field recommend need to be taught in order to produce an effective workforce in cybersecurity. And then I will show us how we can take Bloom's taxonomy, use it as a tool to convert those recommendations into actual learning materials that we can use to teach. So Bloom's taxonomy was originally published back in 1956. It was developed by a group of educators for fellow educators to use in designing effective assessments for their students. It was later updated in 2001 by another group that was led by people who were involved in the original development of Bloom's taxonomy. Anderson was actually a student of Bloom's, and Krathwohl worked alongside Bloom in developing the original version. And this is what it looks like. It's got 6 different levels, and these levels represent the level of knowledge or depth of knowledge that a student would be expected to use for different assessments at these levels. And the pyramid analogy is used here because to operate at any of these particular levels, the student is going to need to be able to perform at all the levels below it. So, for example, to be able to apply knowledge, first you're going to have to be able to understand and also as well as remember just the simple facts of what you're dealing with. And so it's developed for education, but we can really generalize it to the skills or knowledge, to the knowledge that anyone is going to need to solve any task. So at the foundational level, we have remember, which is just the ability to recognize or recall knowledge from memory. And I tried to come up with some CS relatable examples to go along with this. So I would say at this level, being able to remember the function prototype for malloc works here. Knowing what the parameter and the return value is. Then above that, we have understand, being able to construct meaning from material. So if you see a function called to malloc, you are going to be able to read that and understand what's going on, what the function is doing. With apply, we need to be able to use knowledge to implement a procedure or solve a related problem. So in this case, we are going to need to be able to use malloc properly in our own code. We are applying it to some problem that we're trying to code for. Then we have analyze, being able to differentiate, organize, and attribute components and functionality of a concept. So being able to distinguish in a certain case whether we should be using malloc or maybe calloc or realloc, which is going to be most appropriate for what we're trying to do. Above that, there's evaluate, being able to perform checking and critiquing of materials based on standards and criteria. So for this, maybe we need to be able to do some testing of code that could use malloc or just testing code in general. Being able to evaluate it based on those design documents that set up the criteria. And then at the top of the pyramid, we have create, This is being able to put elements together or reorganize existing elements into a new pattern to form a functional whole. One example would be maybe writing your own implementation of malloc, or alternatively, it doesn't have to be from scratch. It could be maybe you took the test results that we used to evaluate, and you're going to use that to modify and optimize malloc for some specific instance you're trying to use it in. So I tried to come up with sort of a simple way to just remember what's going on at each of these levels. And so what I have is being able to remember a fact, then being able to understand its related details, being able to apply that to a problem, analyze different options, and then evaluate the potential outcomes of those, and finally being able to use all of that to create some novel situation or whatever you're trying to do. Okay, so that's a crash course on Bloom's taxonomy. There is a document in the share folder that goes into a bit more depth on it that you can refer to if you like. And so next, I want to talk about some existing recommendations out there on important topics in cybersecurity, what people need to know to be able to perform well in the field. There are 3 specific items. There is the cybersecurity assessment tools. This was published by a research group at the University of Maryland, Baltimore County, and it has 2 distinct components. There's the cybersecurity concept inventory, and then the cybersecurity curriculum assessment, and I'll get into those in just a second here. After that, I'll be talking about the Cybersecurity Curriculum 2017. This was put together by a wide group of people from such other organizations as ACM, IEEE, and a couple other related groups. Again, this document is also in the share drive. It's a bit more extensive, but it's there for you to download and refer, read it at your own leisure sometime. And then there's also the NICE framework. NICE stands for National Initiative for Cybersecurity Education. And this is put out by the National Institute of Standards and Technology. So concept inventories it's a tool used across many fields in education. And generally, these are for assessing knowledge within a specific domain. So that just sounds like testing students, right? But in this case, with a test, you're testing students to assign a grade. But with concept inventories, we're trying to assess specific concepts that need to be taught by a course. So we're doing really evaluation of the course or curriculum with these. They undergo a rigorous development process, and I'll describe the one for the cybersecurity concept inventory here in a second. And they also undergo statistical validation to ensure that they're effective at evaluating whatever course or topic you're trying to. So the cybersecurity concept inventory, I'll just refer to the CCI from here on out, has a number of publications related to its development. I've included the 4 core publications here. The process this group went through was initially to confer with experts in the field of cybersecurity. Mainly, they recruited from academia, but they did also include some members from industry. And they had these experts help identify really some of the key important concepts in cybersecurity that they think need to be taught. And then the group also talked with students to help identify common misconceptions in the field of cybersecurity, because part of evaluating how effective a course is evaluating whether or not students come out of there having corrected some of these misconceptions. So you need to be able to assess that as well. After accumulating all this information, they then use that to create the concept inventory, which is essentially it's a list of questions it's a test designed to test proficiency in these topics. With that, they performed an initial validation using pilot testing and another round of expert review. Based on the feedback from that step, they updated and improved their questions as they needed to get them to be more statistically valid and effective, and then finished up with the final round of validation after that as well. So as an example, and actually, if you're interested, you can find these online by going to prairielearn.org. It's a tool provided by, I think, the University of Illinois, PRAIRIELEARN. And it asks you to sign in. You can sign in with Google. But anyways, they're there if you want to review all the questions on them. You'll have to sign up, or not sign up, but register for a course. It's nothing serious, but then you can go through, find them. They have cybersecurity assessment tools. There's 2 items, and all the questions are there if you want to review them. But just I picked this one as an example from one of their publications. Each of these questions are scenario-based. So the scenario for this one is that there's a law firm which stores sensitive client records in a database on their local network, and then they give you the question: choose the action that is most capitalized, most likely to prevent an opposing law firm from reading the records. And then they have options. And only one of these is correct. 4 of them are what are known as distractors. So 4 of these were actually written based on some of those misconceptions that they helped, that students helped them identify. So for A, we've got require fingerprint scans to access the law offices. B, we've got disconnect their local network from the internet. C is use only trusted vendor software. D, protect the network with a state-of-the-art firewall and intrusion detection system. And E, secure the law offices 24/7 with strong locks and security cameras. So I don't know, does anyone want to take a stab at answering this? I'll give you 10 seconds to think about it. See, so that's, you have to think about it a little bit, and that's how you know it's well designed. The distractors are convincing, so you have to kind of maybe think about it a little bit to help eliminate them. So again, we're looking for the most likely to prevent here. The correct answer is B, disconnect their local network from the internet. In the paper that they put this in, they actually say that D was the most commonly selected answer, so it's the most convincing distractor. And a lot of students, for some reason, think that they prefer using technology, digital-based solutions over physical-based solutions, even when a physical-based solution is going to be more effective. So that's one of those things, one of those misconceptions that needs to be overcome in a cybersecurity course. Each of these questions on the CCI or on any concept inventory are going to be evaluated for their reliability. That is, that the same student will have the same score over multiple measurements. If the question is not reliable, you're not really getting any information from it. The difficulty, which is just the number of students who answer correctly versus incorrectly, as well as the discrimination, which is whether weaker students actually get lower scores than stronger students. And through evaluating 3 of these, you can determine how much information you're actually gaining from each item in the concept inventory. So probably the most important aspect of the CCI that we, from our standpoint, is the list of important topics that they generated during their interview with experts. If we just, as an example, look at the top 5, these are identify vulnerabilities and failures, identify attacks against the CIA triad and authentication, and we learned a little bit about what CIA is yesterday. Devise a defense, identify the security goals, identify potential targets and attackers. So they're a little bit broad, but these are things that this group and the experts they talked with would expect someone, a student who's passed an introductory course in cybersecurity, to be able to have some handle on. Maybe not be experts on them, but be able to answer some of these questions like we saw on the last slide. Along with the CCI, this group also developed the cybersecurity curriculum assessment. The key difference being here that the CCA is aimed at evaluating how well an entire curricula or series of courses is going to train students that take it. And we see that sort of also assumes that the students are going to have a broader base of knowledge on these types of topics at the end of that. And we see that reflected. They have similarly produced a list of topics for this as well. And we see these are a lot broader, such as we look at the top 5: privacy, ethics, authentication, integrity, and confidentiality. These are much more general than the types of topics we saw in the CCI. And so that's reflective of a student having taken an entire degree program or something like that. And they should have, rather than just understanding maybe some attacks that are targeted at confidentiality or integrity, being able to understand as a whole what is confidentiality, what falls under that. So next, I'll talk about the Cybersecurity Curriculum 2017, which was put out by that group. This is people from ACM, IEEE, and some others. This is provided in the share folder if you want to look at it. The main part of it I want to talk about is Chapter 4, which is the content of the Cybersecurity Curriculum Framework. This lays out the types of knowledge that they think are important. They break it down into knowledge areas such as data security, software security, component security, and 5 others. Each of these areas are broken down into units. So within data security, we have cryptography, digital forensics, data integrity and authentication, access control, and others. And then within cryptography, within each of these, they're going to have a specific set of topics. Here in cryptography, they break it into basic concepts, advanced concepts, mathematical background as an example, some others. And each of the knowledge areas, such as data security, has associated with it a list of essentials and learning outcomes, which in the document they describe by saying that students are required to demonstrate proficiency in each of the essential concepts through achievement of the learning outcomes. Typically, the learning outcomes lie within the understanding and applying levels in the Bloom's revised taxonomy. So the people who put this together had in mind when they were doing it, Bloom's taxonomy as a tool for coming up with these. As an example, some of the essentials from the data security, I'll just point us to digital forensics here, which we got to learn a little bit about on Monday with Clem. So associated learning outcomes with that are going to be describe what a digital investigation is, the sources of digital evidence, and the limitations of forensics, as well as comparing and contrasting a variety of forensics tools, which, based on what we learned Monday, now we can do some of these. All right, the NICE framework, which is put out by the very imaginatively named NICE Framework Program Office within NIST. The document designation is the NIST Special Publication 800-181, Workforce Framework for Cybersecurity, and it describes itself as providing a set of building blocks for describing the tasks, knowledge, and skills that are needed to perform cybersecurity work. So the way the NICE framework organizes things is into building blocks called tasks, knowledge, and skills. The tasks are going to refer to, they're going to describe work that is associated with a job role that needs to be able to be done to perform that role. And then the knowledge and skills are going to refer to the learner or worker, what they need to know or be able to do in order to perform that job role related task. The framework comes with a whole series of, a whole list of existing tasks, knowledge, and skills, and you can find those online. I'll provide that in a second here, but it's also designed to be extensible. So if you have some job role that isn't covered specifically already in the NICE framework, it provides step-by-step instructions for coming up with your own tasks, knowledge, and skills in order so that you can create those and then design your own job role and list the skills that you want someone to have to be able to do that job. So a task specifically is going to be an activity that is directed toward the achievement of organizational objectives. As an example, and these examples here are straight from the document, being able to troubleshoot system hardware and software. The knowledge blocks are going to be a retrievable set of concepts within memory, and we're talking about human memory here. They provide the recommendation that organizations developing knowledge statements should consider the learner's different levels of knowledge described in Bloom's taxonomy again. And an example of knowledge would be knowledge of cyberspace threats and vulnerabilities. Skills are going to be the capacity to perform an observable action, and specifically they're meant to use terms that facilitate observability and assessment of the learner. For example, having skill in recognizing the alerts of an intrusion detection system. So you can find this list of tasks, knowledge, and skills online at this status, or you can just Google NICE framework data reference spreadsheet. That'll take you there, and then you scroll down until you find the reference spreadsheet. But it organizes these tasks and knowledge into specific work roles and specialty areas, such as the SPDev one, which is software developer, and just to include some examples here from the framework, some tasks that they associate with this job role are going to be analyze information to determine, recommend, and plan the development of a new application or modification of an existing application, or apply secure code documentation. Some knowledge or skills that they would expect a software developer to have are going to be knowledge of cyber threats and vulnerabilities, knowledge of operating systems, skill in conducting software debugging, and skill in using code analysis tools. There's a lot of others. I just picked these out as examples. And there's a lot of other job roles and specialty areas as well. So now, Bloom's taxonomy, as you saw, was specifically addressed in both the NICE framework and the cybersecurity curricula. And so we can use it to actually work backwards from these learning goals to develop assessments aimed specifically at these. And we start this by looking at these example tasks from the NICE framework or learning outcomes from the cybersecurity curriculum, and figure out which level of Bloom's taxonomy fall under. For example, task 111 from the NICE framework, identify basic common coding flaws at a high level. I would say this sounds like analyze from the Bloom's taxonomy. You have to know what some common flaws are, how to find them, and then you need to perform some code. You have to look at the code and be able to identify them. Task 9, analyze information to determine, recommend, and plan the development of a new application. This is going to be at the evaluate level. We have a keyword in there, analyze, but then you're using that analysis of information to make recommendations and do some planning, which is going to fall under the evaluate level. From the site, we can do the same thing with the learning outcomes from the cybersecurity curricula. For example, from the data security area, we have the learning outcome of explain the concepts of authentication, authorization, access control, and data integrity. Explaining, typically, if you see that as a keyword, that's going to fall under understanding level. Describe the purpose of cryptography. Again, understand, explain, and describe are going to fall under understand usually. And list ways it is used in data communication. So that's going to be a step up, asking them to apply this, some of these types of cryptography. And compare and contrast variety of forensics tools, which we can do to a certain extent. That's going to be analyzed. Now, the CCI, we can take that list of important topics, for example, identify vulnerabilities and failures, and we can assign different types of assessments, or we can design different types of assessments at each level of Bloom's taxonomy. For example, depending on what we want the student to be able to do. If we just want them to remember something under this topic, maybe we just ask them to list types of vulnerabilities. If we want them to have a deeper understanding, then maybe we ask them to define or list key features of specific vulnerabilities. If we want them to be able to apply these, maybe we ask them to identify causal vulnerabilities of the security failure, and we can go all the way up to create, where maybe we provide them a simulation of a system or even a copy of a real life system, ask them to look at it, find vulnerabilities, and then fix them. So if we can sort of do this in a process that mirrors test-driven development in software engineering. If we start with the well-defined learning outcomes that I've been talking about, we can use those to develop the appropriate assessments for those based on, using Bloom's taxonomy as a tool to help us determine what level we need to be testing at to match those desired outcomes. And then based on those assessments, we develop the lessons. So similar to, in test-driven development, you start with the design documents and the requirements, you write the test cases to cover those requirements, and then write your code test tests. All right. So we'll be using that later on in the group activity. And we had a break scheduled at this point. I got through that in under half an hour. So
break, you're 22 minutes before scheduled.
Yeah, I don't see Sola yet.
Well, what certainly we could do is start the activity and have Sola come in later if we wanted to.
Okay. Does anyone have any questions about Bloom's taxonomy or these cybersecurity recommendation documents? Yeah.
Yeah. What was the URL for the shared documents?
tiny.cc/CYSERED. Mm-hmm.
Or another approach is we could just take a break right now.
Yeah, I don't know. I managed to get through that.
I think what we could do is, why don't we just say spend the next 15, 20 minutes looking at the materials.
Yeah, and I guess I can go over these two, or we can go over them together. This is the document that goes into a little bit more detail about Bloom's taxonomy, and there's some good information in here, so we'll go over this, I guess, if it loads. So you can find this online, actually. It's put out by a guy, Leslie Owen Wilson, who's in educational psychology. And it talks about some of the differences between the original version and the new version, a little bit of background on it, why they updated it. It was originally produced in 1956, so a lot has changed since then. This table here provides some interesting information. On the left is the original version, on the right is the newer version. But they have these lists of keywords here that, so if you have a question on, a test or homework or something that's asking to, identify, recall, memorize, recognize, that's typically going to fall under knowledge, or the new version, remembering. One thing they changed from the old version to the new version is they made all of the titles of the levels, they changed them to verbs. So that for assessment, it makes it a little easier because you have the verb. You just think of it as what you're asking the student to do. You're asking the student to remember, to understand, to create. So it makes it a little easier for educators to understand, or anyone to understand, when they're trying to use this. For comprehension, which became understanding, you can see like identify, discuss, describe, explain.
Is there any sense in which the ability to apply higher levels in the taxonomy, and by that I mean analysis, evaluation, synthesis, creating, requires mastery of lower levels? Is there a sense in which there's a foundational level, these levels build on each other?
Yeah, that's why they use the pyramid, I guess. Yeah. Because in order to understand something, you have to be able to remember it. You can't understand what malloc does if you don't remember the function itself.
Right.
Or and you can't write your own function if you don't have an understanding of what you're trying to do, what the requirements are for that. So yeah, that's why the pyramid in comparison is apt, because at each level you have to be able to do everything below that as well. It's progressive.
So one of the things that our colleague Sola is going to talk about is instructional strategies for fostering understanding or fostering skill development at each of these levels. So we're going to, in the activity you're going to be asked to do, you're going to be designing an assessment of some cybersecurity concepts of your choice using these different levels of Bloom's taxonomy. So that's kind of the quick one-sentence summary of what you'll be doing in the group activity.
And we'll try to keep it simple. We're going to stick to the remember, understand, and apply levels. But maybe if we have lots of extra time, maybe we'll try to work together through analyze, or go a little higher. What else?
I guess to orient yourself to that task, you could spend some time in the next 15 minutes. Maybe let's kind of get ourselves oriented into teams and start to, go over the prompt. I think it's useful to do that now. So we have 1, 2, 3, 4, 5, 6, 7 people in the room, well, 9 with us. We have a couple people joining us online. Probably would make sense with the online people in a breakout room. And you can see we have here a document for each team. So why don't you want to self-select your team based on where you're sitting? I mean, the team members are going to have to sit next to each other. So one recommendation I might have is let's do a team of 3 and a team of 4 in here. So, 1, 2, 3, 4, 5, 6, 7. So I don't know, you probably want to join a team over here. Great to have Slater on board as a reality check. We asked him to attend because we want stay honest about this academic mumbo jumbo.
Yeah.
Whether it actually applies in the real world. So, yeah, if you want to join this team here or that team, it's up to you.
And Slater, do you get to do any kind of training, like get to train other people at your work, maybe with onboarding or just like periodically, to, when new stuff comes out?
Yeah, no, I do. Anyone that comes on the team that I work on, me and one person train them. A lot of times the training is diving deep in very quickly and achieve super spend, and then to sync will help you. But that it's probably higher a little bit.
So just arbitrarily, I'll say this is team one. So if you want to go into your team one document, we created a Google Doc for you guys to do your collaboration. You'll be team two. And then online, if you're those of you who are participating online, Arjun, Jim, and Asafah, I don't know if you're going to be doing this, you would be team three. So you'd want to go to the team three document. So James, why don't you open up one of these documents and just kind of walk us through what we're going to be doing?
Sure.
So where is the link for these documents again?
It's, you want to put that up?
Actually, I have it, on slides. Oops. This from current. Well, you can read it there.
It's this right here.
Tiny.cc CySER.
CySER. Tiny.cc.
Chris and James, this is Asafah. You can safely ignore me. I am switching between the two tracks and just visiting a little bit. You're doing an awesome job, but for the purpose of the, whatever you have right now, you can ignore me because I will be jumping out and going to that other session in a moment. James, great job so far.
Thank you.
Okay. So let's get to the document. One of the things we want you to do is we've designated some roles for the group to try to make you work better as a team. So isn't there a document that describes team?
Yeah.
We kind of have a, where's that document? Yeah. So this is like your cheat sheet for doing this activity. So there's the Bloom's taxonomy levels that we want you to think about. And we're going to focus on remember, understand, and apply, correct?
Yeah, so I've got some definitions for those here that you can refer to. And then the instructions here in terms of group dynamics, we have 3 different roles that we want people to assume and sort of work together from these different points of view. One person being a scribe or moderator, and that is you're going to be doing the documentation and sort of just keeping everyone on track and just helping generally with feedback to your team members. And one of you will play the role of an instructor, whether or not the instructor doesn't, it's not relevant, but you're going to be the one who maybe confers with your group members, but ultimately selects a topic and associated concepts that you'll use for applying Bloom's taxonomy to develop some assessments of.
So someone in your group needs to have enough knowledge of cybersecurity concept to be able to write some questions about it.
Yeah, ideally, or if you're more versed in some other area, feel free to use that. I guess this is a cybersecurity workshop, but the important thing here is learning to apply Bloom's taxonomy. So
yeah.
And then
you could choose a topic from the concept inventory or some other topic.
Yeah, and I've provided, there's a picture of it in the, should I open it? It's in the folder as well.
Yeah.
And so then if you have, I guess, the other people in the group, either 1 or 2 of you will be from the roles with students. And so you'll be looking at the topics that the instructor comes up with and the questions that your group comes up with from the standpoint of, is this realistic from my point of view as a student? Do I know enough about this to do this, at the remember level, the understand level, or does it seem like maybe we're kind of going beyond that and something more difficult?
So we have an example here to kind of get the ball rolling. Why don't you talk about that? These are some examples.
Yeah, so these are topics from the CCI list, the list of important topics identified through their expert panel. I think I just put the top 5 here. So they are identify vulnerabilities and failures, identify attacks against CIA and authentication. And so these are a bit general. So, we choose a broad topic, but then a couple related items within those that are more specific that we can actually come up with questions for. For example, from the first one, identify vulnerabilities and failures. Maybe you want to assess students on specific vulnerabilities that facilitate SQL injection, or specific vulnerabilities facilitating cross-site scripting, or maybe looking down at device of defense. You might specifically ask how to go about defending against a specific attack, choose an attack, or yeah.
So to relate this to what we talked about with Slater, imagine you're giving a student an interview, and you want to come up with good interview questions that test these different levels of blooms. I don't know, Slater, if you're consciously thinking about these levels, but these could be really helpful as a conceptual framework for formulating questions that get at different types of knowledge. So, Slater, you might think about this in terms of what are the interview questions?
Yeah, when you're interviewing an applicant, do you expect them to be able to come up with their own zero-day exploit, or do you just want them to be able to remember certain types of vulnerabilities and attacks?
And one of the things we're going to consider later on in the session is what types of knowledge, in terms of these levels of blooms, are going to be most important or most applicable on the job. So that's where, Slater's going to keep us honest with this, to try to come up with questions that are not only at these levels of knowledge, but are also relevant to the real world.
Yeah, so then once your group's identified some topic that you're all familiar with or interested in, and some more specific related items, then you start working through coming up with the assessments. And we'll go bottom up, starting with remember. I'll have you come up with 2 or 3 just straightforward questions that could be used on a quiz or homework assignment to assess whether a student is able to remember key points related to the concepts you've identified. So, this could be something like a multiple choice question, a fill in the blank, something like that. That is just getting at whether the student knows some basic fact and is able to remember it. And then from there, the next level is understand. And so for this, we'll ask you to come up with some more complex questions, or one at least. Maybe we have time for more, but that's going to require a student to perform some of the activities listed in the section for the understand level. So I think there I'm referring to back up here where I talked about understand. That doesn't make it easier. Constructing meaning from different types of functions, be they, where did I copy this one? Be they written or graphic messages, and activities like interpreting, exemplifying, classifying, summarizing, inferring, comparing, or explaining. So I guess the important part is those keywords there at the end. Being able to do those, interpret, exemplify that. So give an example of something. And then at the apply level, this is going to be a little more involved. So you need to take these concepts that you've been testing them on at the understand and remember levels and ask them to apply it to some new situation that maybe they haven't seen before. So come up with a way to assess whether a student is able to apply the concepts you identified in the previous levels. One way to do this could be you can write a scenario and then questions that go along with that, like you saw what they do with the CCI, or maybe you just come up with a high-level description of some sort of simulation or tool, like a capture the flag online type thing, or something like that, that asks students to apply these topics that you're working with.
So are there any questions about what the task is? So what I'd like to do in the next 5 minutes before break is for your groups to brainstorm, pick a set of concepts you want to write questions about. That, and when you got that, you know, probably, what do we want, a couple?
Yeah, like one, yeah.
You know, using these examples, when you've agreed on that, then you're done and you can go to break. So that's your goal before break. So you got 5 minutes to come up with, you know, what's your expertise in your group that you want to write questions about, and then we'll take a break until 10:30.
If you have any questions, please ask.
Yeah.
Let us know.
You want to put that, well, he's dropped out. So.
Jim's all alone, I guess.
Yeah.
Group of one. Oh, and also I have some examples at the last part of the document here, but yeah. Refer to those if you need to.
We're just choosing one topic.
Yeah, yeah, one topic and maybe, you know, maybe a couple different subtopics that you can ask questions on. So maybe so that, you know, you can come up with a couple different types of questions. Maybe, yeah, if you can come up with multiple questions on the same thing, just ask different things about it, that's fine. Just, you know, use the topic, but
Assessment points table.
in the, so assessment points, this one?
Yeah.
So that would be, these are the items you come up with that you're going to answer questions about. So
Okay.
what's that? Yeah, the description of what you're testing on.